Theta is represented as an angle of inclination and it is represented in the coordinates of r comma theta. So any complex number z is equal to x plus iy represented using a point p of x comma y in a coordinate plane. Again, theta will be equal to minus alpha in the fourth quadrant based on the function tan. We are discussing the theta here. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Here in this session, we will be taking the polar formation of a complex number. So what do you mean by the polar formation of a complex number? Complex number is usually represented in terms of a real numbers a and b. So when it is expressed in terms of an angles, then it is nothing but the polar form of a complex number. So here we are going to study in detail about polar form of a complex number. Now, what do you mean by polar form of a complex number? So here, look at the diagram given here. So we have an x-axis and y-axis here. So clearly, I have taken a point P here, point P whose coordinates are denoted in terms of r comma theta. Usually the coordinate plane will be in terms of x and y. So these are all polar coordinates. So therefore, the distance is taken as r and theta is represented as an angle of inclination and it is represented in the coordinates of r comma theta. So whenever the complex numbers represented in the form of the coordinates r comma theta, they are called as the polar form of a complex number. Here r is nothing but the modulus of a complex number, that is nothing but distance of a point, this complex point from the origin, that is the modulus of a complex number, and theta is called as the argument of the complex number. So here we have the formula for the complex number in terms of polar form, that is any complex number in the polar form can be represented as z is equal to r cos theta plus I sin theta. As I said, r is nothing but the distance of a point from the origin that can be found by taking the modulus of a complex number, and theta is nothing but the angle of inclination made by the complex line to the x-axis here. So any complex number z is equal to x plus iy represented using a point p of x comma y in a coordinate plane. But in the polar coordinates, it is represented where x is taken as r cos theta and y is taken in terms of r sin theta. So therefore, here generally z, if you replace x and y by r cos theta and r sin theta, you can take r outside, then you will get form of r into cos theta plus I sin theta. This is the polar form of complex number. We have certain important points to remember while studying the polar coordinates. As I said, r is nothing but your modulus of z. How you will get the modulus of z? By taking the square root of the real numbers in the complex number. So any complex number in the form of x plus iy can be taken as square root of x square plus y square to find the modulus. Well, modulus z in terms of polar coordinate, it is nothing but r. So it is nothing but the modulus of z, and I said theta is called the argument of z or amplitude of z, and it is usually denoted by argument of z or amplitude of z, that is arg of z, amp of z. Next, to find the value of theta, if theta lies between minus pi to plus pi, it is called as principal argument of z. This, as you have studied in terms of trigonometric equation to find the principal solution which lies from 0 to 2 pi. In the same case here, whenever theta lies between 180 to minus 180, that is pi to minus pi, it is called as principal argument of z. And as it is written in the form of arg of z or amp of z. Next, how to find a theta? So we have many types of complex number, that is purely real complex number. When we say it is purely real, when the imaginary part is 0. So whenever the z is purely real, then the point lies on the x-axis. On x-axis, the y-coordinate 0. What is the y-coordinate in terms of polar coordinate? That is r comma theta. So theta must be 0 on x-axis. So therefore, x will be greater than 0, then theta is equal to 0. If x is less than 0, then theta is equal to pi. Depending on the value of the positive or negative value of x. So since it lies on the x-axis, means we have two cases. That is, if this is the x coordinate, if a point lies here, then the angle here will be 0. That is, theta will be 0. If a point lie here, then the angle is here. That is nothing but 180 degrees. Therefore, it is pi. Next, we have if z is purely imaginary. Purely imaginary means it is nothing but the real value, that is a is 0. So, therefore, it lies on y-axis. Usually in a coordinate plane, x is called the real axis and y is always considered as the imaginary axis. Now, if it lies on the y-axis, we have two possibilities. One is the point may be on the positive y-axis or the point may be on the negative y-axis. If the point is on the y-axis, then the angle is plus 90. If the point is on the negative side of the axis, then the value is minus 90 because we measure it clockwise. So therefore, the value will be minus pi by 2 if y is less than 0, plus pi by 2 if y is greater than 0. Next, we have one more condition. Let us take some tan alpha is equal to modulus of tan theta. If here alpha lies between 0 to pi by 2, that is only in the first quadrant. You can see this is your first quadrant, 0 to pi by 2. So if it is between 0 to pi by 2, we have four cases. How we can write theta in terms of alpha? Theta will be equal to alpha if z lies in the first quadrant. Remember, where is tan positive and negative in the four quadrants? We know tan is positive in first and third quadrant and negative in second and fourth quadrant. So according to that, we have to change the theta. So in the first quadrant, theta will be equal to alpha. In the second quadrant, theta is taken as pi minus alpha. If you substitute tan, then it will be minus tan alpha. Next, then theta will be alpha minus pi in the third quadrant, and again theta will be equal to minus alpha in the fourth quadrant based on the function tan. We are discussing the theta here. So this is how we can find the value of theta when it lies in the four quadrants. Next, find the modulus and the arguments of the following. So let us find the modulus and arguments of the following. So let us find what is the value of x if this is in the form of x plus iy. So clearly you can see x is equal to 1, y is equal to 1. So therefore modulus is nothing but r, which is nothing but square root of x square plus y square. So here this is 1 plus 1 is equal to root 2. Next we have x is equal to r cos theta. So this implies cos theta is equal to x divided by r. So what is the value of x here? It is 1 and r is root 2. So cos theta we got is as 1 by root 2. Next we have y is equal to r sin theta. So sin theta will be equal to y by r. So again it is 1 by root 2. For what values of cos theta? It is equal to 1 by root 2. So 1 by root 2 is for cos 45 degree, that is cos pi by 4. So similarly for sin theta, if it is 1 by root 2, the value is sin pi by 4. So therefore the theta value is here pi by 4. So therefore this is the argument or amplitude of the given complex number. So next we have root 3 minus I. So let us compare this with x plus iy form. So the value of x is root 3. The value of y is minus 1 here. Now we need to find the modulus, that is r of a complex number. So how to find the r of a complex number? R is square root of x square plus y square. So root 3 whole square is nothing but 3. Minus 1 whole square is 1. So it is root 4, which is equal to 2. So therefore the modulus is found. Now next we have x is equal to r cos theta, or directly you can write cos theta is equal to x by r. So let me write here cos theta is equal to x by r, sin theta is equal to y by r. So here it is root 3 by 2. So for what values of cos theta? It is root 3 by 2. And here it is minus 1 by 2. So cos theta we can write it as root 3 by 2, but sin theta is minus half, which can be written as minus sin pi by 6, or this is nothing but sine of minus pi by 6. That is for sine 30 degree it is half, but we have minus outside, which can be written as sine of minus pi by 6. When theta, we know the general form, that is z is equal to r into x cos theta plus I sin theta. So the theta value for cos and sin must be same. You can see here for both it is pi by 4 and pi by 4. So here if one angle is minus pi by 6, then other angle must also be equal to minus pi by 6. And also remember cos of minus theta is nothing but cos theta only. So whether you write minus pi by 6 or plus pi by 6, the value for cos remains same, that is root 3 by 2. So I can also write this as cos of minus pi by 6 to make theta equal in terms of sin and cos. So therefore theta will be here minus pi by 6. So this is the argument of the complex number root 3 minus I. Next we have convert the following complex number into polar form. As usual, whatever you have did in the previous session, find the modulus, find the argument, substitute in the general equation. Let us take this in the form of x plus iy. So x value is minus 1, y value is 1. So r is equal to root of x square plus y square, which is nothing but 1 plus 1, which is equal to root 2. Next, we need to find out theta. So for that, I'll use cos theta is equal to x by r and sin theta is equal to y by r. So let's see now, cos theta is minus 1 by root 2. So when you have minus for cos theta it is minus of cos pi by 4. When you have minus of cos theta, replace it by pi minus pi by 4. So it becomes cos pi minus pi by 4. So when you write this, cos theta will be cos 3 pi by 4. So for cos 3 pi by 4, it is minus 1 by root 2. Similarly, here you get sin theta as 1 by root 2. So here also you can write theta as 3 pi by 4 only, because once you have got theta in terms of cos, it is same in terms of sin also. Now we have found r and theta, so therefore the general form will be x r cos theta plus I sin theta. So therefore z is equal to here. So what is the value of r here? It is root 2. So cos theta is nothing but cos 3 pi by 4 plus I sin 3 pi by 4. So this is the polar representation of the complex number. The next form, root 3 minus I, clearly x plus iy means x value is root 3, y value is minus 1. We have already done to find r and theta in the previous problem. Let's look at that problem now. So for root 3 minus I, we have got r is equal to 2 and theta is equal to minus pi by 6. Since we get sine as negative, so which is minus pi by 6. So the theta is minus pi by 6 here. So here just we are writing it in the polar form. So you have to find the value of r, which you will get is 2, and theta you got it as minus pi by 6. You have to find these values, then substitute in the general equation r cos theta plus I sin theta. So which will be 2 into cos of minus pi by 6 plus I sine of minus pi by 6. So this is the polar form of the given complex number. Next we have 1 plus I root 3. So clearly we have x is equal to 1, y is equal to root 3. So let us calculate r, which is x square plus y square, which is 1 plus 3, which is equal to root 4, which is equal to 2. Now r found, cos theta, which is x by r, sin theta, which is y by r. So cos theta is x is 1 by 2 and sin theta is root 3 by 2. So for what values of cos? Theta is 1 by 2. That is for 60 degree. So therefore theta is 60 degree, or in terms of radians it is nothing but pi by 3. For sin also here theta is pi by 3. So therefore z is equal to r is 2 cos pi by 3 plus I sine pi by 3. So this is the polar form of the given complex number. So in today's session, we have learned how to express a complex number in a complex plane to a polar form of a complex number, that is in the form of z is equal to r cos theta plus I sine theta. We'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.